Welcome to today's session on Paper 1 Prelim Revision for Grade 12 Maths. We've got a lot to cover. Should take us about an hour and a half to an hour and 45 minutes. But that will also depend on questions and what we're going to do today. So what's in Paper 1? Well, we've got algebra, patterns, sequences and series, functions, finance, calculus, and probability. So before we begin, just some good exam tips. And here I'm specifically speaking to students. So teachers, please forgive me. But this is always good advice to pass on, although students never tend to take it from a teacher. But anyway, so firstly, I think for everyone, including teachers, make sure you get enough sleep. And then start studying for maths a long time in advance. And the reason for this is because maths is such a practice subject. It's not just theory. And I'll show you a little bit of why I say that. Because you've got to practice, sometimes you can get stuff wrong. So if you're only practicing the night before, how can you learn what mistakes you're making and fix those mistakes? Which is why I say practice for a long time in advance, so that you can go back to your teacher or you can find help online, or etc. etc. So you've got time to find help and to figure out where you're going wrong. Okay, and then when you do practice your questions, first try the question before you check your answer. Don't just check the answer first and then say, okay, I see where I'm supposed to go with this. First try the question and make sure that you understand it. Or if you don't understand it, then go back and check. But first actually try it before looking at the answer. Okay, then of course, eat healthy. And then on the day of the exam, bring a spare pen, pencil, and razor, and make sure your pens work. So bring 3 if you have to. Make sure your pens work. That's the last thing you want, is to borrow a weird pen that doesn't feel right. When you practice, use the pen that you're going to write your exam with, or a same pen that you're going to write your exam with, because when you see your practice all the time in that pen, and then you write your exam, it doesn't feel like you're making mistakes. If you do make a mistake, it's not, you can see the mistake, not because it looks weird, because it's a different pen. Okay, just psychology. Also, don't talk to your friends about the exam before you start writing the exam. It's terrible. It will make you nervous. It'll give you anxiety. Just avoid it. Also, sometimes other people get stuff wrong. So if they're telling you one thing and actually you've learned something else, just ignore them. Okay. Form a study group. So yes, don't talk to your friends right before the exam, but study together, because that also helps. Some people might understand one section better and they can help explain it to you. When I did my matric year, I had a friend that I always used to go study with, and we did very well at the end of the year because we practiced our maths together, so we could help each other out. And then if you are stuck, do ask for help. And then during the exam or before the exam, bring a watch with you, because you can't always see the clock, or at least that was me at the beginning, and it will help you to plan your time as well. Okay, so how will you be tested? Basically, there are 4 levels of questions in your exam paper. So knowledge, routine, complex, and problem solving. Now, knowledge is theory. Okay, so how many degrees on a straight line? 180 degrees. That's knowledge. Okay, routine is being able to factorize. Complex is being able to solve or do a little bit of thinking. So these are questions that are worth 3 or 4 marks. And problem solving is advanced questions. Okay, and we'll see one of those right at the end of the paper. And I must be honest, it caught me a little bit for surprise. So then, of course, all of your questions will be situated around these marks. So if you're studying at the last minute, study functions and graphs and calculus first, and then do algebra, patterns, and sequences and series before moving on to the other sections, so that you know these best. Okay. Then work out how much time you have for each question. So I've actually done it here for you. This is actually standard in a prelim. So you have 150 marks, you have 3 hours, and you have 180 minutes. That means you have 5/6 of a mark per minute. Okay, so if a section is 22 marks, I've actually worked this out the wrong way around. You should have 180 minutes divided by 150. So it's actually going to be 6/5 minutes per mark. That's a better way to do it. Okay, so if you have 22 marks, you have 22 times 6/5, And we'll just do that quickly on my calculator. So 22 times 6/5 gives you 26 minutes to complete a section. Okay, so I'll change that, but I'll share this with you at the end of the session as well. Oh, before I continue, let me just share the exam paper that we're going to be doing today. So we're going to do paper 1 of 2020. Okay, so there I've shared it in the chat function, so you can just download it from there. Okay, then right before the exam, read through your exam paper, mark the questions that you know that you can do, and start with those first. Okay, because you know that you've got it, they're easy, it will help relax you as much as you can be relaxed for a maths exam, and then calculate how much time you have to spend on each section. Okay, make sure you're comfortable. So wriggle, because it's going to be very awkward when the whole exam hall is quiet in the middle of the paper and then you want to wriggle. Close your eyes, breathe deeply, and count to 10. That's very important, just to give yourself some space and center and focus and not think about chaos. Okay. And then, of course, to think about what you want to be doing after the exam. So think of something fun and exciting, whether it's a nap for 3 hours after your exam, or if it's eating an ice cream, whatever your reward, I put that in inverted commas, you're going to give yourself for getting through this math exam. So think positive. And then, guys, please bring tissues to your exam. There's nothing worse than someone sniffing in an exam. At least it used to drive me insane. Okay, so I wanted to just show you an example of the memos. So this is one of the pages of the memos. And I wanted to point out the ors. Okay, so firstly, can you see the ors? They tell you that there are different ways to answer a question. So if you like a particular method, use that method, okay? Because most of those methods, as long as they are mathematically correct and you found them in a maths textbook, you will be given the marks for them. Okay, and then do you see that you have a lot of marks down the side here? And that is because you need to show you're working out. If you don't show your y as the subject of the formula, you're not going to get a mark for that. So you're going to miss out on it. So make sure that you show all of your steps and you're working out. Okay, so with algebra, things to remember, you need to be able to complete the square and you need to be able to factorize trinomials where a is not equal to 1. Okay, and then of course your quadratic formula, memorize the formula. Yes, it's on your formula sheet and that's fine and great, but learn it anyway. It's very important. And then of course, remember your log and exponent rules. So here's the first set of questions we're going to do. And then mostly I've just typed them out again. So when it's quite basic and routine, I'm not going to spend too much time on them because I want to do the more complicated questions with you. Okay, so this one here, we can easily see there's 2 x's. So our common factor is x. We take out x and we have x minus 6. And it is asking us to solve for x. So then we have x is equal to 0 and x or x is minus 6 is equal to 0 or x is equal to 6. Okay, make sure you do all of the steps. So you'll get a mark for factorizing and then a mark, half a mark here and half a mark here. Okay. Then here it says correct to 2 decimal places. So this is actually asking you for your quadratic formula. Now remember to write the formula down before. Oh man, I've written this terribly badly. Sorry. Yay. That's b squared minus 4ac over 2a. Okay, you can see I spend a lot of time doing that. But learn the formula. And I learned that in grade 12, grade 11, when we first taught it. Okay, so I just want to show you something really nice. So here we can see a is 1, your b value is plus 10, and your c value is 8. Okay, so you do actually need to substitute it and do the steps over here. Okay, and then use your calculator to simplify for you. Okay, 4 times a is 1 and c is 8. Okay, over 2 times 1. So I'm so sorry for my atrocious handwriting here. So we're going to actually just chuck this into the calculator now. So I'm going to show you two methods. I'm going to do it with the numbers very quickly, and then I'll do it with the other method, which is really nice. So it was -10 plus or minus. I'm just going to use a plus. Square root 10 squared minus 4. A is 1 and C is 8, right? Over 2 times 1. So I'm just going to leave it as 2. And there's your first answer. Then what you can do, and you can obviously leave it in thirds, but it's asked you for 2 decimal places. So you can just change it and round it off. Now, what you can do is just press second function and your left arrow again, and then just scroll to behind the plus button, use your backspace, put in a minus and say equals, and there's your other answer. Okay. So that's the one way. Now, the other way is you can actually save into your memory keys. So A is 1, B is 10, and C is 8, right? And then we type in the formula using our memory key. So it takes slightly longer, but if you want to reuse the formula, all you have to do is then restore your memory values into the calculator. Okay, so we've actually just typed in the formula with the plus over the ends, and there we go. So same. And then again, if we press left and then second function left, just takes us right to the beginning of the expression, and we can do that one and equals. Okay, so that's just a nice quick way to do it on your calculator as well. All right, then here, I should actually move this out the way so I can see. So for this one, it's actually, we need to draw a graph. So I'm going to obviously just first multiply this out so I can see what type of graph it is. So I've got 1x and plus 2, and then minus x squared, and then minus 2x. So if I write this in standard form, it's going to be minus x squared and minus x, and then plus 2. So I can see that my graph is a sad face. Okay, and we can see here quite easily that it's either 1 is equal to x or x is equal to minus 2. Okay, so we're going to draw our Cartesian plane. We're going to have minus 2 on this side and 1 on this side. And we're looking for where it's less than 0. In other words, where it's below this line here. Okay, so it's at this point where the graph is going downwards. So it's going to be x is less than minus 2. And on this side here, where x is less than 1. So those are your two answers. Then on this side, you can see this is quite a long one. So we need to first obviously square both sides. Okay, and by squaring this, your positive or negative goes away because a positive squared is a positive and a negative squared is a negative. Okay, so we just have on the side x plus 18, and on the side we have x squared. And I like to call this the Mickey D rule. It's for your middle term. So obviously you're going to square the first term. You're going to square the second term, which is going to be plus 4 over here. And then don't forget your McDonald's. So you're going to have x times minus 2 times 2. Can you see the m? So it's going to be minus 4x. Okay, don't forget that. If you're going to not remember the Mickey D's rule, rather put your brackets down and write them down so that you can remember to do your FOIL. Okay, that's a very common error, and I've seen it a lot with students. So don't forget either McDonald's or to write out your brackets. Okay, and then of course we can just simplify. So on this side we can have 0. So it's going to be x squared minus 4x plus 4 minus x minus 18. And then we simplify x squared minus 5x and minus 14. Okay, then factors of 14 that make 5 will be 2 and 7. So we'll have 0 is equal to x, and my 7 is the one with the minus, and x and plus 2. And then of course x is equal to 7 and x is equal to minus 2. Okay, so there's a mixture here. This is routine procedure here. And then this here would be complex solving. Okay, right. Then here we have solve simultaneously for x and y. So we've got x plus y equals 3, and then we've got this big one. So we're just going to take one of these to the other side and make either x by itself or y by itself, up to you. So whatever makes you happy. Here, because I can see there's an x squared, what I'm actually going to do is get y by itself. Okay, because I don't want to put another, I don't want to square a bracket. So I'm just going to say y is equal to 3 minus x. And I call this equation 1. And I call this one equation 2. And then I tell my examiner that I'm going to substitute 1 into 2. Okay, it's just mathematically a nice thing to do is to explain what you're doing. Okay, so that they can follow you. So you have 2x squared plus 4x. Your y is now 3 minus x. So use your brackets. Minus your y is 3 minus x is equal to 15. And then we solve again for x. Okay, so I'm not going to do it because we've done lots of solving of x's and factorizing. So once you get the x value, you'll get 2 x's because you have an x squared here. Okay, so 2 x's, and then you will then substitute those 2 x's into your y. Okay, so you'll have y is equal to 3 minus 1x, and then 3 minus the other x, and you should get 4 answers altogether. So 2 x's and 2 y's. Okay. Then this one, I had to read it 3 times. If n is the largest integer for which n to the power of 200 is less than 5 to the power of 300, determine the value of n. Okay, so that's a huge number right there, this 200. So we could take root 200 of n and root, but that's, I mean, that seems very complicated. So what we're going to do is I'm just going to take out a common factor of 100, right? I have n to the power of 2 to the power of 100. Same, is less than 5 to the power of 3 to the power of 100. Okay, so that gives 3 times 100 is 300. So we can then see that both sides have 100, and we can basically, I'm saying in inverted commas, we can cancel them out, and we can just work with what's inside the bracket. So now we have n to the power of 2 is less than 5 to the power of 3. And so when we have a square root, we can just say n is less than 5 to the power of 3 over 2. Cool. All right, fantastic. Any questions on algebra? We all good? Awesome. Okay. If you do have questions, pop them into the chat or the Q&A function, and I'll answer them as I see them coming. Okay, so with sequences and series, you do have 3 different types of patterns, and you need to remember the formulas for all 3 of them. Okay, so you've got linear and arithmetic patterns, which is a common difference, and it's always a first common difference. With geometric, it's a common ratio, so you're either multiplying or dividing by the same thing. And so we call the ratio, we don't always say divide, we just turn it into a fraction. Okay. Then with a quadratic function, you have a second common difference. And if you learn this set of formulas here, which we'll come back to in a few, then you'll be able to find your formula quite easily. Cool. So here's our first quadratic, patterns question. So it says 7xy and then minus 11 is an arithmetic sequence. So we know it's a common difference. So we have 7, and we have x, then we have y, then we have minus 11. And we know that the difference between the two is equal to the difference between these two is equal to the difference between these two. Okay, so then we can just simply solve for x and y. Okay. Here we're given the quadratic pattern, so we know it's the second common difference. So we've got minus 3, 6, 27, and 60, right? So it says determine the general term of the pattern. So first we have to do our little sticks. So 6 minus 3 plus what will give us 6? Well, that will be 9. And this here will give us 21. And this will give us 33. And then the common difference here is 12 each time. So we can see it's a second common difference or a quadratic pattern. Then we have these formulas, A plus B plus C. Then we have 3A plus B, and then we have 2A. And these are equal to this first row here. Okay, so we've got minus 3, we've got 9, and we've got 12, and we need to then find the pattern. So I'm just going to do it quickly because we actually need it for the rest of the questions. So 2A, 2 times what will give me 12? A will give B 6, right? Then we substitute A in here. So 3 times 6 is 18. We take it to the other side, becomes minus 18. So B is equal to minus 9. Then we put these in here. So we've got A is 6 and B is minus 9. That gives us minus 3. So we've got minus 3 plus C is equal to minus 3. And obviously then C is equal to 0 because we've got minus 3's on both sides and they cancel out. Okay, so our formula then is, I'm just going to write it down the side here, Tn is equal to 6n squared minus 9n, like so. Okay, I'm just going to write it down on my side so that I've got it for reference purposes. So Tn is equal to 6n squared minus 9n. Okay, so from there, we're going to move on to the next question, and it says calculate the value of the 50th term. So all this is a substitution. So you can have Tn is equal to 6n squared, which we just found. Okay, then we substitute in a 50. So we've got 6 times 50 squared minus 9 times 50. And we simply put that into the calculator and find a value. Okay, so let's do it quickly. So we've got 6 times 50 squared minus 9 times 50. And so our 50th value is 14,550. Okay, so very quick and easy. Yeah, as well. Can I show you something really awesome? So don't tell your teachers I showed you this. Okay, so in stats mode, you can use this formula here, a plus bx plus cx squared. It looks pretty familiar, right? So all they've done is switch the a and the c around. So we can actually put our pattern into here. So our x value will be our term position, and our pattern will be our term value. So that's 1. Then we've got 6. Then we've got 27, and then we've got 60. Okay, so once you have those and you've typed them in, you can just say change. Okay, and then to get the formula or to check that you've got your formula correct, you say alpha 8 and you just press 1 for regression value. Now remember to substitute it back into the formula the way that they've written the formula here. So you can see C is 6. So in other words, 6x squared minus 9x plus 0. So it's exactly the same formula here as well. So it's just a really nice way to check that you've got the right formula, especially because your other questions rely on this formula that you've now found. I see there is a question, so I'm going to pop in and look. Okay, thanks, Lee. I'm sorry that it's so cold in KZN. That sounds terrible. Okay. So then it says, show that the sum of the first differences of this pattern can be given by 6n squared plus 3n. Okay, so this sounds more complicated than it actually is. Remember we did this, okay? So we had minus 3, we had 6, we had 27, and we had 60, right? And then we had 9, 21, and 33, okay? And then our sum of our first n differences. So they're actually talking about this here, but this is a first term work in an arithmetic sequence because we have a common difference of 12, right? So we can use our arithmetic sequence and knowledge to solve this question. So it's just asking you for the sum of the first n values of this pattern here. Okay, so we know our D value is 12 and our A value is, so I'm going to make D obvious, and A is 9, right? So then what we do is we have our Sn is equal to n over 2, 2a, and this is just a formula on the formula sheet, which I have learned off by heart. Okay, and then we just substitute in our values. So we still need an Sn, so that's not going to change anything. N over 2, 2 times a is 9, plus n minus 1, d is 12. Okay, and let's just simplify here. N over 2, this becomes 18, this becomes plus 12n minus 12, right? Okay, and then we can multiply, let's just simplify this. So this becomes 6 plus 12n, right? So we've got n over 2 times 6 plus 12n. So I've just taken 18 minus 12, right? And then we just multiply this in to get our final thing. So 6 divided by 2 is 3. So we've got 3n. And then over here, we've got 12 divided by 2 is 6. And we've got n times n is n squared. And does that look like what we were looking for? Yes, it is. So we have figured it. Then it says how many consecutive first differences were added to the first term of the quadratic number pattern to obtain a term in the quadratic number pattern that has a value of 21, etc., etc. So we're looking for, if we're looking at the pattern here, here's 3, then we've got, minus 3, we've got 6, then we've got 21, 27, and so on, okay? And they're asking us if this quadratic pattern here is 21,060, how many of these did we add, right? So it's just going to be one less than that term position, right? Make sense? So if we can either do it this way, where we can have Tn is equal to 6n squared minus 9n is equal to 21,060, and we just solve for n, and then we just say n minus 1 will be how many quadratic patterns or how many first differences that we added to it. All right, for this question we have proved that this is convergent in geometric series. So first thing that we need to do is just substitute k in a couple of times so that we can find our ratio, because when we asked for a convergent geometric series, we need to prove that our ratio is between -1 and 1. Okay, that's what we're looking for. Okay, so it only converges when your ratio is between -1 and 1. Okay, so we'll say k is 1, then we have 4 times 3 to the power 2 minus 1 is going to be 4, that becomes 1, so 4 times 3 is 12. Then we have k is 2, so we have 4 times 3, 2 minus 2, so that's 0. Anything to the power of 0 is 1, so we have 4 times 1 is 4. Then here we have 4 times 3, and then we have 2 minus 3, so this becomes minus 1, so this becomes a third, so we have 4 over a third, right? So we can see that our ratio, if we are dividing each time, is 1 over 3. Okay, so we have proved that our ratio lies between, so we say therefore our ratio is equal to 1/3, and therefore it converges because it lies between -1 and 1. Okay, then here it's a nice problem solving question, and it also was like, hang on, let me just think about this. So luckily you're watching this for the second time. So it's asking you to determine the value of p. So it's saying k is p. In other words, you're starting with p. Okay, so if we have 4 to the power of 3 times 2 minus p, and we're looking for a sum which is equal to 2 over 9, right? So I just had to think about this for a second because I'm having a moment. Then we have our ratio is still going to be 1/3, right? Okay, and our first, this is our a value over here. Okay, so our sum to infinity is given by a over 1 minus r, right? So this is our a value because p is our first initial value. So that's going to be, 4. So that's going to be 4 times 3 to the power of 2 minus p over, and then our ratio is 1 minus 1/3, okay, which we've already worked out from there. And that's all equal to 2 over 9. Now we can solve for p, right? So we're going to have, sorry, don't actually do that. 4 times 3 to the power of 2 minus p, and that's all over 2/3 is equal to 2 over 9, and now I've run out of space. So I'm just going to work this side here quickly. So let's just go here. I thought I gave myself enough space, but I clearly didn't. So what we're going to do is we're just going to multiply 2 over 9 by 2/3, right? So 2 over 9 times 2/3 is going to be 4 over 27. So we have 4 times 3 to the power of 2 minus p is equal to 4 over 27. Then we can divide both sides by 4. So we have 3 to the power of 2 minus p is equal to 1 over 27. Now we know 27 is 3 to the power of 3, and because it's underneath 1, it's going to be -3. So we have 3 to the power of 2 minus p, and that is 3 to the power of -3, and therefore we can now say 2 minus p is equal to -3. So we're going to have, we take that to the other side, becomes -2. So it's minus p is equal to -5. So p is equal to 5. Okay. Cool. Are we all happy there? I think that's the end of pattern sections. Any questions? All right, fantastic. Let's go through functions. So you need to remember your function theory. It's very important. There's always going to be theory questions on functions. It's easy marks. Learn your formulae and recognize your graph by its shape, by its formula, and by its characteristics. So it doesn't have one asymptote. Does it have 2 asymptotes? Where are those asymptotes? Where do those asymptotes intersect? And then think about your inverse functions. What is an asymptote? Remember, it's anything which cannot be divisible by 0. So it's a little stripy line that says cannot divide by 0. So there's no valid answer here. Okay, and then remember, how does shifting a graph work? If you shift it up and down, you're just adding or subtracting the value of q. But when you shift it left or right, remember you have x minus p, so that is equal to 0. So x is equal to p means you've shifted it to positive, which is to the right. If you have x plus p in your brackets, then it's going to be x is equal to -p, and that means you have shifted to the left. Okay, now there is a whole section on functions that we did for term 2, so with lots of revision theory. So if you'd like, just remind me at the end and I will send that revision set to you as well. Oopsie, let me just clear this all away. All right. Okay, so questions. It says, I don't know if okay, so the first question says, write down the equations of the asymptotes. Theory question, right? Here's your asymptote. Cannot be equal to 0. So you're going to have x minus 1 is equal to 0, or x is equal to 1 is asymptote. And your other asymptote is here, which is your y asymptote. And that's going to be y is equal to 2 to shift up and down. Okay. Let me just write down this. I think it's in my notes. Cool. So then the next one says, Determine the equation of the axis of symmetry of H that has a negative gradient. So they don't want both. They just want where your gradient is equal to -1. Okay, and your gradient for an axis of symmetry is always a -1 or a +1. Okay, then the point where it goes through is your point where your asymptotes intersect, which is at 1 and 2. And we found that from our equations of our asymptotes, right? So all we have to do is we've got y is equal to -x because it's our negative gradient plus c. And then all we do is substitute in our y and substitute in our x, and we find our c is 3. Okay, so very easy. It's a nice, lovely use of theory. Okay. Then it says sketch the graph of H showing the asymptotes. So if x is equal to 1, we're just going to do a straight line and the intercepts with the axes. So when we have intercepts, you need to find the place where x is equal to 0 and solve for y. And then, of course, where y is equal to 0 and solve for x. Now, on your calculator, you can also do it here and find a really nice table set of pairs. So I'm just going to say I'm going to go to my table mode, and I'm just going to type in the formula for my hyperbola. So it's going to be -3 over x minus 1 plus 2, and we're going to go look here and look at our graph. So there's your asymptote. It's obviously an asymptote. You've got the striker line. It's telling you at x is equal to 1, draw a striker line. Now, if we go up the table, you can see that it just gets closer and closer and closer to 2 the further x goes. And if I look on this side, sorry, I went a very long way just to prove a point. But if we look on this side here, you can see it's getting closer and closer and closer to 2, but it never ever reaches 2. Okay, so 2 on your other side is your asymptote, which we've already proved because we know our theory. But it's just nice to remember that if you have a moment of panic. So obviously, you don't want to plot the graph with 500 points, but I do want to show you that you do need to have a couple of points between 1 and 0, wherever your asymptote is. So our asymptote is at 1, so we're going to start at 1, and we're going to make our step 0.2. Okay, and that's just to give you a better indication. It's to draw a more accurate graph, so you can see you've got a better idea of what's actually going on. It's getting closer and closer as we go through. And here on this side, you can see much bigger values. So again, it's just to give you that shape of the slope as well. Okay, then this one is you've got the graphs f of x, which is a half x plus 5 squared minus 8, and g of x, a half x plus 9 over 2. So this is a straight line, and this we can see is a parabola, and it's sketched for us here. So here's our f and our g line. I'm sorry, I try to enhance the pictures a bit, but some of them did not come out very clearly at all. So the axis of symmetry of f intersects the x-axis at E, and the line G at D is equal to MN. Okay, and C is the y-intercept of F and G. Okay, so it says write down the coordinates of A. So let's just go back and look. A is our turning point, and we can see it's been given to us in our parabola formula. So it's going to be x is -5 and y is -8. That is our turning point for A. Okay, it's your minimum value of your graph. Then write down the range of f. Well, f is here, and range is all your possible y values. So it's going to be y is greater than your minimum value, which is -8. So y is greater than -8. Then calculate the values of m and n. So here at A, our x value is -5. So our d value, which is a straight line, is our x value, or m here, is going to be -5. Then all we would need to do to find our n value is substitute our -5 into here and then solve for n. Okay. Then it says calculate the area of OCDE. So let's go back and look at our picture. So we've got OCDE, DE, which is a trapezium or a parallel trapezium. So what I'm going to do is I'm going to break it down into a triangle and a rectangle, right? Okay. So we know at the point C is our C intercept here, which is 9/2. So this point here is 9/2. And at D, our Y value is, let's just chuck it into our calculator quickly and find out. So we said M is -5. So we're just going to have, let's just go home quickly. So we're going to have a half. Right, so a half. And then we've got -5. And then we've got +9/2. And that gives us 2. So our Y value, or N, is 2, right? So let's go back to our picture here. I'll just redraw it in. I'm sorry, it always loses it when you switch between apps. So we had 9/2 here. We had our triangle, and our N value was 2 over there. So this rectangle, the length is 5, right? So the area of this rectangle, DEO, and this piece here is going to be 5 times 2, which is 10, right? Then here we've got a right-angled triangle. So the area of a triangle is half times base times perpendicular height, right? So we've got a half. Our base is going to be 5, and our height is going to be 9/2 minus 2. I'm going to do it on the calculator so that you can see, because otherwise I'm going to lose all my working out. I'm just going to do it here on the side. So 9/2 minus 2 is going to give me 2.5. Okay, so then we're going to have a half times 5 times 2.5 gives me 6.25. So the area of my triangle is 6.25, right? So I've got an area of 10 and an area of 6.25. So my total area is 16.25. Okay. Then it says determine the equation of G to the -1. In other words, the inverse of G in the form Y is equal to. So let's just go back and write down what our G is. So it's going to be G of X is equal to Y, which is equal to a half X plus 9/2. Okay. So when we want to do the inverse, what we do is we switch our X and our Y around. Okay, so we switch, every Y becomes an X and every X becomes a Y. And then we have to get Y by itself in order to get the marks. So that's one mark for switching them. And then, of course, to make Y by itself will be your other mark. So we take this to the other side. So we have X minus 9/2 is equal to a half Y. And we multiply everything by 2 to get rid of the half. So we have 2X minus 9 is equal to Y. So that is your inverse graph for a straight line. It's a pretty straightforward one. It's quite a nice one to do. Okay. Oh dear, we should have written that down. What was it? Y is equal to 2X minus 9. Right. Okay. So if h of x is equal to g minus 1 plus k is a tangent to f, determine the coordinates of the point of contact between h and f. So if h of x is a tangent to f, then that means that the gradient is the same. So we know that the gradient from g to the minus 1 is 2, right? That's what we just found just now, okay? So we need to find the gradient of f, where the gradient of f is 2. So let's just go back to our f and look at the formula quickly. So we've got, I'll just write it here, half x plus 5 squared minus 8. Okay, so let's go back. So where we've got some space. So we've got f is equal to, my goodness, I'm really shockingly bad here, sorry. So we've got a half and then x plus 5 squared minus 8. Okay, now when we want to find the gradient, what do we know? We know calculus, right? So we have to find the gradient of f that is equal to 2. But we cannot derive this here because it's not multiplied out. So we first need to simplify it. Okay, so we're going to have a half, and then we've got, oh, I'm in the wrong question, but anyway, it's fine. We've got x squared plus, remember McDonald's, so x times 5 times 2 is 10x. And then this one squared is 25. And then we've got minus 8. So we've got a half x squared plus 5x plus 25 over 2 minus 8. Okay. So we can then find the derivative, okay? F prime x. And we're just going to say 2 times a half is 1. So it's going to be x. And then x to the 1 times 5 is just 5, and then x goes away. So that's our derivative over there, and we know it's equal to 2, right? So now we can solve for x. So x is equal to minus 3. Okay, so that is the points where x is equal to minus 3. Sorry, where your gradient of f of x is equal to minus 3. So then we can go back and substitute minus 3 into here to get our y coordinates, and then we can solve. We can just go to the next page. So we want to determine the coordinates of the points of contact between h and f, and in fact, this is our coordinates here. So if we just substitute in minus 3 into our equations, we have x, which is minus 3 plus 5 squared minus 8 is minus 6. So our points of contact will be minus 3 and minus 6. Cool. Then this question says the graph of f of x is equal to 3 minus x is sketched below. A is the y-intercept of f. B is the point of intersection. Sorry. You should know better than to copy. B is the point of intersection of f, and the line y is equal to 9. So in other words, it's giving you the y coordinates. So it's asking here's x, and the y value is 9. Okay. So, sorry, let me just clear this. Let's go and look at our question. So our first question says, write down the coordinates of A. Now, A is the y-intercept, which means x is 0. Anything to the power of 0 is 1. So our A coordinate is just going to be 0. X is 0 and y is 1. Then it says, determine the coordinates of B. Well, we know that our y value is 9. So I'm just going to do it here. So we've got 9 is equal to 3 to the negative x, right? And then, of course, we solve for x. So 9 is actually 3 squared. And we've got 3 to the negative x. So our bases are the same. So we say 2 is equal to minus x. So x is equal to minus 2. Does it make sense on our graph? Yes, it does. There we go. So our coordinate of B is minus 2 and 9. Don't forget to write it down because that's what they actually asked for. Then it says, write down the domain of f to the minus 1. In other words, the inverse of f, okay? So when we take an inverse, if our domain is in our normal graph, then it will be our range in our inverse graph. So we're actually looking for the range of this graph here. And our range is just from x is greater than, sorry, y is greater than 0. So when they ask for our domain, it's just going to be x is greater than 0. Okay, then it says describe the translation from f to h of x as 27 over 3. So it's just multiplied this by 3 to the power of 3. So it's increased the graph 3 times. So it's actually just made the graph much, much bigger. Then determine the values of x for which h of x is less than 1. So here we've got 27 over 3 to the x is less than 1. Okay, so we're just going to simplify this. So we're going to have 3 to the power of 3 times 3 to the power of negative x is less than 1. So we have 3 to the 3 minus x is less than 1. Now anything to the power of 0 is 3, right? So it's going to be 3 to the power of 0 here. So we have 3 minus x is less than 0. And so we can see that we're going to have, if I take x to the side, it's just going to be 3 is less than, sorry, x. Okay. Right, so with finance, any questions so far? Feel good? I know it's a long one, but it is the entire first paper. So, cool. All right. So remember the difference between a future value annuity and a present value annuity. A future value means you're putting money aside for later. Present value annuity means you are paying for you're paying something off that you got now. Okay. So present value annuity would be a home loan or a car loan. Future value annuity would be a retirement fund, or if you're saving up to buy something later. Okay, then remember your formulae. Yes, they are in the formula sheet, but it's a good idea just to brush up and make sure. But with finance, definitely go back and check your formulae as well. There is a study guide chapter on finance for grade 12. So if you need help with that, I'll share this presentation with you at the end and you can just click on this link. Make sure you know how to use your calculator and make sure that your battery is fresh on the day. Okay, so here's our question. On the 31st of January 2020, Tepel made his first monthly deposit of 1,000 Rand into a savings account. He continues to make monthly deposits of 1,000 Rand at the end of each of the months up until the end of January 2032. The interest rate was fixed at 7.5% per annum, compounded monthly. What will the investment be worth immediately after the last deposit? Okay, so how many years has he been doing this for? Well, 32 minus 20 is 12 years. Okay, and then it's monthly, so it's times 12. The interest rate is going to be 7.5%, and then that's compounded, so it's divided by 12. Okay, our X value is obviously 1,000 Rand. And so we just substitute this into our future value formula. Okay, now, can I remember what the future value formula is? So it's going to be X, and then it's going to be 1 plus I to the power of N minus 1 all over I again. Okay, and then we'll just substitute this in so that we can just do this quickly on the calculator. That'll be the easiest way to do it. So we have 1,000, 1,000, there we go, brackets, brackets. 1 plus your interest rate is 0.7, 0.075 divided by 12, right? And then that is to the power of N, which is 12 times 12. And then we say minus 1, and we close that bracket, and then it's the 0.075 divided by 12. So after 12 years, it's 232,435 Rand. Then the next question says, if he makes no further payments but leaves the money in his account, how much money will be in the account? So this is just a compound interest for 1 year. So what we're going to do is we're just going to take our value, which we've got, and we're going to say L for answer, and we're going to put it in a compound interest formula. So with the same interest rate that we had over 12, and then to the power of 12 times 1, so we'll just leave it as 12. So he has a total of 250,480 Rand in his account at the end of 2033. Okay, then this one, Jim bought a new car for 250,000 Rand. The value of the car depreciated at a rate of 22% per annum according to the reducing balance method. So in other words, say compound interest. Okay, it's not, if it was a straight line method, it would be obviously a simple interest. After how many values will its book value? So this is actually, we've got to just put it into our formula. So write down your formula first. Okay, so it's our A value is our final amount. So that's going to be 92,537.64 is equal to 250,000. And then it's 1 minus, and our interest rate is 0.22, and we're looking for N. Okay, so then we obviously divide both sides by 250,000. So I'm just going to leave it as is because we'll just substitute it into the calculator with all of the beautiful stuff here. That's 250. And this side will be 0.78 to the power of N. Then this, because we cannot find N without using trial and error, but you have since learned about logs in grade 12, you can use the log. So we know a log is log, base, answer is equal to exponent. Okay, so what we're going to do is we're going to have log of our base is 0.78. Our answer is this one here, which is going to be 92.5 blah 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 over 250 blah blah blah, and then is equal to N. And then all we do is type it into our calculator. So we're going to say second function and our pi button, and then our base is 0.78, and our answer was 92,537.64 over 250,000. Is that enough zeros? Yes, it is. And then we say equals, and it gives us N is equal to 4. Okay, so that's that one there. Then it says somebody takes out a loan. The interest rate is 11.3% per annum compounded monthly. The period of the loan is 6 years. The monthly repayment on the loan is 1,500 Rand. And the first payment is calculated 1 month after the loan is granted. So calculate the value of the loan. This is a present value formula. So we're just going to substitute that in. And then what you can do is, once you've worked out the present value, what you use, so how much interest will pay in total. Sorry, I'm just going to rush through this because we still got quite a bit to do, and it's already been an hour. So the present value, and then how much interest will she pay? Well, we work out the present value, and then we say 1,500 times 5, and it's monthly, so times 12 would be how much she paid. And then you take that value and you subtract it from your present value to be the amount of interest paid. Okay, calculus. So there's always at least one question with first principles. Okay, so learn your formula, and then remember your derivative quick rules. And then with your derivative quick rules, remember first to simplify out and make sure each individual thing is one term. If it is not one term, you cannot derive it, and it's going to give you issues. Okay, pay attention to your substitution. It's very important. Remember how to factorize your cubic equation. So you can use your table mode or use your K method, whatever makes you happy. And then remember to simplify your roots and powers, and pay attention to whether they ask you for a positive exponent or a negative. Okay. So I'm not going to do this one, but what I mean by pay attention to substitution is when you have f of x plus h, right? You have here 2 times x plus h squared minus 1. So pay attention to where you substitute your x plus h and make sure you do the whole thing. Don't confuse it and then leave your h on the outside of the brackets, because then it's going to be completely wrong. And if you want, check your answer at the end with your short substitution. So we know at the end that we should get an answer of 4x, right? Here, determine, and then it's given you differentials. So here you can't do this derivative first. First, you need to simplify it to 2 over 5, and then you can differentiate it. Here, it's a fraction. So first, factorize. So we're going to have 2x minus 3 and 2x. Sorry, my mouse is hassling me. Plus 3, right, all over. And then here we can take out a common factor of 2. So we have 2x plus 3, and then we can cancel across. So we're left with a half times 2x minus 3, which we can easily differentiate. So we'll just multiply this in. So this will just be x minus 3 over 2. So our derivative will be 1. Okay. For this graph, this is a really great question. So I do want to go through it because it's not something that's commonly seen. So they give you the graph, they tell you it's a cubic graph, and they tell you that there is no d. Okay, and that's because it goes through the point 0 and 0. Okay, so you've got ax cubed plus bx squared plus cx. And then you have a y-intercept at 0, and then your x coordinates of your turning points are -1 and 2. So in fact, they're telling you the derivative is there. So your first question says, for which values of x will g increase? So here we can see it's decreasing. Here we can see it's increasing, and again it's decreasing. So the values where g will increase will be between x is greater than -1 and x is less than 2. Then write down the x coordinates of the points of inflection of g. So here it will be the midpoint between the two of these. So half of -1 and 2 is going to be 0.5. So it'll be somewhere around here is your point of inflection. For which values of x will g be concave down? Well, g is concave up here and then concave down between 0 and your other x-intercept. If g prime x is equal to -6x squared plus 6x plus 12, determine the equation of g. Okay, so we know that g of x is equal to ax cubed plus bx squared plus cx, right? And we're given that g prime x, if we just factorize this quickly, is going to be 3ax squared plus 2bx plus c. And that's where this formula is. So these just match. So 3a is equal to -6, 2b is equal to 6, and 12 is equal to c. So it's really quite straightforward. So we can see that a is going to be -2, b is going to be 3, and c is equal to 12. So we can easily find the equation of g. Let me just write this down because I think I need the next one. So we've got g of x is equal to -2x cubed plus 3x squared plus 12x. Okay, so remember we've actually got to write down the equation here. So we would finish off our equation by saying -2x cubed plus 3x squared plus 12x. Okay, so make sure that you actually answer the question and not just leave it half hanging there like I did as well. All right, then it says determine the equation of the tangent to g that has a maximum gradient. Write down the answer in the form y is equal to mx plus c. So we already have the equation of the gradient, right? It's going to be this previous formula here, which is negative. So let's just write it down quickly. So it's going to be -6x squared plus 6x plus 12, right? And then they're asking you for the maximum gradient. So they want you to complete the square here and find your y-intercept, your y turning point, maximum of your parabola, right? So we can just take out a 6 here. So we're going to take out minus 6. We're going to be left with x squared minus x minus 2, right? Then we complete the square. So we have x squared minus x plus a half squared minus a half squared minus 2. So our maximum gradient is these two together. So it's going to be -2 and a quarter. Why does that feel so wrong? Oh, sorry, you must multiply the 6 back in. So times by 6. So we're going to have -2 and a quarter times by 6, -6. So your maximum gradient is going to be 13 and a half. Okay, so that's your maximum gradient of your equation of the thing. So if you want the equation of the tangent to G with the maximum gradient, so our maximum gradient is 13 and a half, and then write down your answer. So now we have y is equal to 13 and a half x plus c, right? Then we can find our x coordinate, which is going to be x minus a quarter. I really should have simplified this properly, shouldn't I? Then your x coordinate is 1/4, right? That's at your, that's the point where your gradient is a maximum. So we can substitute the x in there. And then we need to also substitute that quarter into your original equation, which was -2x cubed plus 3x squared plus 12 in order to find your y value. And then once we have that, we can substitute them in and we can solve for c. All right, great. I'm going to leave this one because I don't want to run out of time and I really feel like it's 2 o'clock. So, cool. So with probability, there is a study guide chapter here for you, so you can just download that. I'll share it at the end. And then if it helps, draw a picture, and it really, really does help. And I'll show you in a minute why it does help. And then don't make it unnecessarily complicated. Think about it. Think about the information they're giving you. Draw your picture and then fill in the information. Okay. So it says, in a certain country, 10-digit telephone numbers with the following format were introduced. So you have an area code with 3 digits, an exchange code with 3 digits, and a number code with 3 digits, okay? And all the digits are 0 to 9, right? So you have 10 possible options. So how many possible 10-digit telephone numbers can be formed? Well, you have 10 here, 10 options here, then you have 10 options here, and you have 10. Okay, I'm just drawing this picture because it will help with the next question. So we multiply all of these, so they are 10 to the power of 10 different possible 10-digit telephone numbers which can be formed. Okay, so let's just remember that because it will be important in the next question. Now it says there are certain criteria. So the area code must be 3 digits and the first digit cannot be a 0 or a 1. Then the exchange code must be 3 digits and the first and second digits cannot be 0 or 1. And the number must be 4 digits and the first digit must be a 0 or a 1. Okay, so how many valid 10-digit numbers? So again, we're going to draw our little stripes. Okay, and we're going to just go through the information. So the first 3 digits and the first digit cannot be 0 or 1. So that takes 2 options out of the 10 away. So we're left with 8 options. Then the other 2, it doesn't specify, so we still have 10. Your exchange code must be 3 digits and the first and second digits cannot be 0 or 1. So again, we're going to have 8 and 8. And the last digit is going to be 10 because you can have any options. Then the last one says must be 4 digits and the first digit must be a 0 or 1. So you only have 2 options here and then the rest you have lots of options. So that gives you this answer here. Okay, so obviously you'd have to do this step, show this working out, and then calculate your value. Then it says determine the probability of any randomly chosen 10-digit telephone number would be a valid number. So this is your valid probability, and you're just going to divide that by 10 to the 10, and it's going to give you an answer for 10.282. Cool. Harry shoots arrows at a target board. He has a 50% chance of hitting the bullseye on each shot. Calculate the probability that Harry will hit the bullseye in his first shot and his second shot. So here we're going to draw ourselves a tree diagram, right? So the chance of him getting it right is 50% and 50% here. Okay, I'm just doing it very simplistically because I'm terrible with this mouse. Okay, so 50% means a half, right? So he has a half a chance of getting it right and a half a chance of getting it wrong. And they're asking for getting it both in his first and second shot. So it's only this branch here. So when we go across branches, we multiply. So it's going to be a half times a half. So he has 1/4 or 25% chance of getting it both, hitting the bullseye twice in his first and second shot. Then it says calculate the probability that Harry will hit the bullseye at least twice in his first 3 shots. So you're just going to extend your tree diagram here. And then you're going to count at least twice. So 1, 2, and 3. So that's 1/8. And then you've got 1 wrong and then 1 right. So that's 1/8. So that's there. Oh, that's also this one here. So that's another 8. So you'll just add all your 8s up where the branches work, and then you'll find that sum. Then Glenda also has a 50% chance of hitting the bullseye on each shot. Harry and Glenda will take turns to shoot an arrow, and the first person to hit the bullseye will be the winner. Calculate the probability the person who shoots first will be the winner of the challenge. So here, I had to really go and look at this, I must be honest. So you have Harry is either going to get it right or he's going to get it wrong in his first shot. So if he goes first, then it's Glenda's turn. Okay, then it's his turn again. So the pattern is going to be 0.5 plus 0.5 to the power of, because now we're in the third row, 3, plus, and then it's Glenda's turn, so we skip, then it's going to be 0.5 to the power of 5, and so on. So you can see this is actually a geometric pattern. So what you would have to do is say a sum to infinity, and then your ratio, which is 0.5 squared. Okay, and then you'd have a, which is 0.5 over 1 minus r, and you just solve for it like that. Okay, cool. That is everything. Guys, are there any questions? We did it a bit faster than yesterday. Oh, last time. Awesome. All right. In that case, let me just sign off on YouTube and then I'll chat to you quickly. Guys, joining us on YouTube, thank you so much. We hope you found this useful. If you do have any questions, you're welcome to pop them into the comments down below. And please feel free to subscribe for any other videos that we will be doing in the future.